What am I? Extinct or dormant or active maybe, lava and magma. What could this thing be? This can create dark clouds, but they don't contain snow. Beware of falling ash and the hot lava flow. There are 45 active ones on the island of Java. If one of them were to erupt, you would see lots of lava flow. There was one of these called Krakatoa, which erupted in 1883. It was heard 3,000 miles away and was one of the worst in history. These are objects which can erupt, like Vesuvius that destroyed Pompeii. They pump out lava and magma and spray ash and rock which land miles away. If you guessed a volcano, you are correct. Your objective today is to learn the types of volcanoes and the parts of volcanoes. Let's look at this diagram of a volcano. You'll notice that there's lava flowing out, and there's ash and a gas cloud, the crater here at the top, and a vent, along with a magma chamber. So let's look at what those are. Magma is found beneath the center of the earth. It's very, very hot, melted rock. The vent is an opening in the earth's crust from which lava, ash, and hot gases flow or are ejected during an eruption. Lava is the magma that erupted out of a volcano. It flows down, then it cools and becomes rock. This lava is normally or always black whenever it cools. A crater is the cavity on top of the volcano, or actually anywhere on the volcano depending on the type. It's shaped like a bowl, and it's where a vent occurs, which is how the magma and gases escape from the volcano. The conduit is this right here, and it's called a conduit because it's the path the magma takes out of the volcano up to the crater.
Our planet has a violent soul. Majestic and often destructive, volcanic explosions rattle our collective imagination. Krakatoa, Mount St. Helens, Etna, Eyjafjallajökull, the images simultaneously strike fear and awe in our hearts. But how did these giant mountains form, and where does all that destructive force come from? At least 50 eruptions rock the Earth each year, meaning our planet is literally bursting apart at the seams. The Earth's crust is made up of about 17 slabs of land called tectonic plates that float on the superheated magma that makes up most of the planet's interior. Magma is the Earth's lifeblood, churning restlessly beneath the crust. And wherever it can, it's trying to burst through. It's at these spots that volcanoes form. Our planet is home to some 500 active volcanoes. While some volcanoes, like those in Hawaii, break through a thin point in the crust called a hotspot, the vast majority of volcanoes occur on active fault lines where tectonic plates meet. The most volatile region is the Ring of Fire, a geological fault belt that rims the Pacific Ocean and holds roughly 75% of all the Earth's volcanoes. Typically, volcanoes take one of two forms. Shield volcanoes, wide and broad with lava usually slowly oozing out of them, and composite or stratovolcanoes, steeper and more violent. When hot liquid magma reaches the surface, whether in a slithering flow or a booming eruption, we call it lava. Though molten lava may seem threatening, it's not known to move quickly. A volcano's pyroclastic flow is far more deadly. This poisonous ash cloud can race down the slope of a volcano like a bullet train, obliterating everything in its path at speeds topping 100 miles per hour. It's what stopped the residents of Pompeii dead in their tracks. But despite the volcano's brutal destruction, it is also a force of beauty and rebirth for the planet. Lava creates new lands where life can flourish. Like it or not, volcanoes are part of the planet's life cycle. As the Earth continues to explode, gurgle, and slither its molten heart out, we must learn to live side by side with its awesome power.
Wow, I thought that was a really cool video. You'll remember she went through the 3 types of volcanoes. First, there's a composite cone. These are very tall with steep sides. They can even be as tall as 8,000 feet. A couple of examples are of Mount Rainier in Washington State, Mount Fuji in Japan, Mount Vesuvius in Pompeii, Mayan volcano in the Philippines. They have steep sides, as we mentioned before, and those steep sides were created by multiple eruptions over time. They built up to create a tall volcano. You'll notice up here the vent, the crater, it's bowl-shaped. But this volcano can also have multiple vents in multiple locations. This is a picture of Parecutin in Mexico. It was taken in 1943. You'll notice this one has steep slopes with a crater and a flat top. These volcanoes are usually 1,000 feet high or less. They form on the side of other volcanoes, like a composite or a shield. They can appear quickly within just a few years, not over time like the composite volcano. This volcano is a shield volcano. The Hawaiian Islands were built from shield volcanoes that built up over time and created the islands. They are the least explosive, meaning that their lava typically flows instead of throwing cinders and rocks out. They're dome shape with gently rolling slopes and hills. The lava flows down the hill, sometimes following a geographic form like a river. They also form lava tubes. These are pictures from a family vacation to Hawaii at Volcano National Park. This is an arch, a sea arch, which was created by the lava flow from Kilauea. This is an example of a lava tube, which we just learned about on the page before. They're a little bit like a cave, but they were formed by lava. You'll see the black rock because that's the lava after it hardened. And they're very easy to navigate with a flashlight because you can't get lost in it like you could a cave. It usually has an ending, so you walk in and you can turn around and walk back out. This particular one actually has an opening on each end, so you just walk through it. And here is a crater with an open vent you see here with the volcano ash and gases escaping. And these are my children when they were 4 and 5.
It's a glimpse into the center of the Earth. It's like listening to the heartbeat of the planet. The physiological effects of being inside the volcano are significant in that you have every force down there trying to kill you.
All right, so let's use the drone to...
I wanted to share the Marum crater that's located in the island nation of Vanuatu by bringing a team with me and documenting this place in a way that's never been seen. The drone that we used is called the Phantom 2 Vision Plus. We had also GoPros mounted onto these particular drones with gimbaled devices so that no matter how much they shook, the video remains stable. We were able to take a series of thousands of photographs around the top of the crater and then process those using a specialized software to render the first of its kind 3D model of the volcano from inside. We were fortunate in that we got the footage we were looking for, and unfortunate in the fact that we lost our drones. They fell to their demise, some into the lava and others just from the incredible amount of heat and unstable air. You have sulfur dioxide and toxic gases that are superheated and just an incredible radiant heat that exceeds 1,000 degrees Fahrenheit standing right next to it.
Take your time, dude.
Well, if you're looking for extreme locations, it doesn't get much better than an erupting volcano on Vanuatu. We were there to investigate how quickly microbial colonization happens on rocks. We certainly wouldn't imagine that there is life in the lava lake itself, just way too hot for anything to happen. But the instant the rock cools to below about 120 degrees Celsius, it's considered a habitable environment. Getting a handle on how microbes can colonize this particular substrate is a good example of what will happen across the planet and has happened across the planet throughout geologic time. Having the cameras everywhere, particularly during the sampling at the very edge of the lava lake, is critical because we can go back and see exactly how far we were from the edge, exactly how closely distributed these newly formed rocks were. This isn't something you can measure in the moment. 3D reconstruction of the crater itself will be very useful, and figuring out which layers are iron-rich, which layers are sulfur-rich. Within the caldera as a whole, there's certainly life. Coating the walls as you go down, on some of the surfaces down at the bottom, almost certainly there's a high microbial constituency.
The greatest scientific value is just having videographic support that can be used in tandem with other research that's happening in the world. I really believe there's an opportunity to merge those worlds of exploration and tech, and coming back and reporting on all kinds of information that has not yet been discovered.
Wow, I think that was a really cool video showing all the lava and then the drones that went in. And of course, as they mentioned, they were sacrificed because the extreme heat and lava caused the drones to be destroyed. One cool thing about volcanoes is that even though they create mass destruction of land, they also, just like forest fires, bring back new life as new plants can start to grow over time and create new life because of the richness of the iron and different things that are inside that rock. Now, for your assignment, I would like for you to write down something that you learned today, something that you found exciting or interesting, and then at least one question for class time that we can discuss as a class. And here's our credits. We used videos from National Geographic, and then we also have credited our photographs and also our the other works that we used in this video. This presentation was created with PowerPoint, videos downloaded using keepvid.com. The recording was through Screencast-O-Matic, and then it was uploaded to YouTube for your viewing enjoyment.